Welcome to another episode of Through the Noise. I'm trying a new format, so this is going to be a little bit different. My guest today has a really intriguing product. It's related to concrete and cement. I know that might not be that exciting to some of you, but this guy can make something that's better product, better, cost less, and it's better for the environment. It can capture CO2 into the product forever. So check this out. It's a great episode. Thanks for listening or watching. This show is about organizations using new technologies to adapt to the realities of climate change. Chris, you're the CEO and co-founder of CarbiCrete, and I have been intrigued about this particular area. And you have, what I think is quite an innovative approach to dealing with the the cement part of things. So before I just mangled the introduction to you, why don't you give us a little bit about, your dinner party and somebody asks you, what do you do? What do you typically tell them when you kind of want to start a conversation?
First of all, I say I don't want to bore you, but cement is one of the most polluting products on Earth, and it's actually responsible for 8% of the greenhouse gas emissions. I'm working on a way to replace cement with a industrial waste byproduct as a binder. We've also use CO2 to actually cure the concrete. So there's three things we do. We get rid of steel slag, which is the input to the concrete. We replace cement and we cure it with CO2.
That probably before we dive deep into the aspects, and I want to try to understand the chemical engineering parts of this best I can, but I'm not an expert. But just to give us some kind of context, you said 8%, and I looked up a few things, and it was, if the concrete or the cement creating industry was one country, it would be like the third largest sort of emitter of CO2 to the world. So just kind of give you a sense of scale behind China and the United States, right? So the process of cement is difficult, right? Because there's they put stuff in a tumbler, then they inject super amounts of heat that creates CO2, and then it creates this thing, I guess it's called clinker or something, that gets ground up, and then that goes into a cement bag, right? And that's the binder, right? That's the stuff that goes into then concrete, which is like sand, rocks, and other things to get it to stick, right? Am I on target? Did I do my research right?
That's exactly right. So they stick the limestone into a kiln, and fire it up to more than 1,000 degrees, and they actually burn the limestone, and they drive off the carbon dioxide from the limestone to leave what is known as clinker. And so you're exactly right.
So it's the fossil fuels to burn the stuff, and then it's the stuff that gets ejected as part of that separation process, if you will, that
right.
It's just extremely polluting, right? And so here I was looking at cement going, okay, well then I look up your company and you have a way of binding CO2 into it. And I just, for some reason, I got in my brain that you're binding CO2 back into the cement in some way. But
yeah, it's a reversal. It's a reversal of the process, basically, right? So, we're basically making calcium carbonate from the steel slag, which is our precursor material.
And the steel slag, where does that come from? That's steel making stuff, right?
Yeah, so there's 250 million tons of it made every year with not a lot of purpose to it. It's generally used as aggregate, a very inexpensive aggregate, or it ends up in landfill, and it's a direct result of making steel. So you need to make steel slag to make good steel. It's just all the minerals that get driven off of the steel during the conversion process.
So I, just thinking the end product is sort of, or at least what I think is the end, your process helps these manufacturers that make these concrete blocks, right? It's fundamental. I mean, it doesn't have to be a block, but it's part of that, right? You're creating a slightly different type of concrete block with the steel slag that goes into it as the binder.
Yeah, it's slightly different. It looks the same, acts the same, has the same characteristics, if not stronger, and same chemical composition. So, we take a different path to get there.
Okay. And then this stuff, the way you do it, you actually inject CO2 into the heating, the curing process, and you lock some CO2 into the product back
Yeah,
again.
yeah, that's exactly right. So,
Right.
it's just like a regular concrete plant. You've got sand or aggregate, you've got water, you've got a binder. In our case, it's ground steel slag. You mix it up in a big industrial grade, mixer, effectively, and then you put it into a compression machine where it gets made into a block or a brick or a paving stone or something like this. And that's the exact same process as is used today. The only difference is that once it's made into a form, it goes into a different curing system. So instead of injecting heat and steam, and we inject CO2, and the CO2 actually binds together with the steel slag, and it creates that stable carbonate, calcium carbonate, which is effectively limestone.
So are you removing the cement binder? Your products don't need the cement binder, but you're removing it.
Yeah,
It's the binder is the steel slag. That's the waste product that's just sort of sitting around or going to landfills.
exactly. We don't use cement in our process.
Okay. Okay. So you got to give us the story on how you got into this line of work. Like, you just walk by a steel mill and you're like, oh, what's that stuff? And let me stick it in here and see if it sticks. see if it,
That's funny. I'm the business guy. The
yeah.
this is my second startup. My first
Okay.
startup was in solar power, residential solar power, which we sold our company back in 2014. And then after a year of not doing too much, I was introduced to the folks at McGill University, which is where I went to school as well. And I found out a whole bunch of things. Number one, cement is not an innocuous white powder. It's actually super
Mm.
nasty. Number two, you can replace it with something that is not used. It's the steel slag. And number three, you can cure it with CO2, carbon dioxide. So this is back in 2015 when nobody was talking about how bad cement was. Now it's like on every other TV show or in every other magazine. It's always being talked about now, as something that needs to be fixed. So I'm like, well, I mean, if it solves these three problems and it makes a product that you can explain to your grandmother, we should work on this and make this into a company. So myself and the inventor, we formed the company in 2016. After a year of discussing, and then we add quickly some more team members, and we've grown to a team of 25 now.
Oh wow, fantastic. What I'm curious about is, I mean, it's probably very hard to figure out like the just how much carbon, because you're not going for carbon neutral in a sense with this process. You're going carbon negative, right? You're putting more of it into it than perhaps the older process of creating the cement is emitting. So, like, do you have some, I don't know, some ways of explaining it to somebody like me that doesn't understand, like just how much are we talking
Yeah,
about?
yeah. So if you could explain it like a concrete block, and sorry, I'm speaking in metric terms. I'm in Canada, so
Okay.
the a regular concrete block, a CMU, a cinder block, is about 18 kilograms, and normally there's 2 kilograms of cement that go in there, and for those 2 kilograms of cement, they would have emitted 2 kilograms of CO2. It's one for one,
Wow. Okay.
and so we
Super cool.
avoid
Okay.
so we avoid 2 kilograms of CO2 emissions just by not using cement. Then, furthermore, we can bury up to a kilogram of CO2 into the product. So, 2 kilograms of abatement and 1 kilogram of complete carbon removal. So, in an 18 kilogram block, we've got roughly 15% of abated and removed CO2.
Okay. Okay. All right. Well, okay. Well, then this leads to probably the mechanical engineering questions of like, well, how much? Okay, what properties are different than from the end product? Like, does it make a more flexible thing, or the compression is not like? What are the trade offs? There's got to be a trade off, right, in this space.
The trade-offs, there's not a lot of trade-offs, other than the fact we use a bit more steel slag than cement in the concrete mixture. So I'm not sure if that's a trade-off. It's just it's a fact of of the mixture. And it actually is a nicer looking product because of that, because there's more finer aggregate. It looks like an architectural product. It's actually better in durability. So that's freeze and thaw. It's about 20% better. So it's actually a better product. It looks better. And it's less expensive because we're using a waste byproduct. And in fact, it's carbon negative. So it's something that we should all be using, quite frankly.
So is it like the concrete? If they make this stuff into concrete blocks, are the blocks just like smoother? Is that what it is? Is it just a finer looking piece of concrete?
Yeah, it's smoother. Yeah.
Okay. Then are there cost issues? Like, does it cost more? Like, I'm trying to play devil's advocate. Like, what's the problem with it then?
Well, there's no problem. The question is, we're trying to scale up right now. It actually costs a little bit less, because the materials are waste byproducts. So, the question is just like scaling up. And we're also changing an industry that's been doing the same thing for same thing for the longest time. So it's basically getting people to change.
So you got a product that's probably has some better qualities. It's cheaper if we can scale it, and you're reusing or repurposing waste product that would have gone into landfill anyway, and you're sequestering CO2 a pretty significant sum if you're getting the 2 kilograms out by not using the cement, and you're getting another kilogram per unit of whatever, right?
Yeah.
Is that about right?
Exactly. Yeah.
Okay. All right. So okay. Wow. So what's the scaling process look like? I mean, what do we need to do? Just put a bunch of these machines near steel mills, or
yeah, you need to install grinding systems near steel mills, like on the steel mill plants. You need to convert customers their curing systems to accept CO2, and that's it. So there's not a lot that has to change in the whole grand scheme of things. So it's just a question of scaling and getting to that size.
Okay. Now I know that that of course, I come from the tech world, and this disruption's like the thing that people want to hear in technology. Oh, this is going to be the next disrupting whatever. But in reality, the way I think about it, especially when we're dealing with the pressures of climate change that are upon us, you got to think through also to some degree what the impact will be, right? If you could scale your product, scale it to size. And one of the things I was thinking about, well, the cement guys making the cement right now probably can't stop doing that immediately, but they're generating CO2. So in theory, they could probably give you some of that CO2 for your processes.
Yep, absolutely. What's coming to the stack is actually pretty CO2 rich. So we're in the process of getting several flue gases formulated for us to try in our process. Currently, we're using packaged gas, but we want to use flue gas and other things like that. Or direct air captured gas, to be quite frank.
Huh. And okay. And then I guess the guys, you sell this process to the guys that are making the concrete blocks or making other concrete things, yep. Right? And what's the footprint what's the retrofitting? Like, they're probably using the old way with the cement stuff. You come in and go, there's a better way. What do we got to do?
Yeah, there's not a much for the footprint of their building. It's not that big of a change. You're just changing the curing systems, right, to accept CO2 instead of heat and steam. So there's not a huge footprint change. In fact, if anything, we can save them land. So if somebody was starting from scratch, they'd be way better off doing our process, because when the blocks come out of the curing system the very next day, they're ready to ship. And you can use them the very next day. With regular concrete blocks, you have to wait 28 days for them to get full strength. So a lot of these companies leave the blocks
28 days.
Yeah.
A month.
Yeah, so yeah.
To sit them out somewhere in a warehouse to sit and dry.
Yeah, not in a warehouse. They can sit in the field, but still, that's land, right? And they just can't. I mean, after 7 or 14 days, they can ship them, but they still, they need the 28 days to reach full strength. So that's a major, impediment to new plants being built, right? Half the cost is land, so we don't need that. And what's more, the other cool thing about our process is that it only cures in CO2. So a lot of guys don't tell you this, but like when they're making masonry products, they have to clean all their machines, every day, and that includes like scraping off set concrete,
Before it
right?
dries on their
Well,
machines, right?
well, it
Ruin
does
it.
dry. It does dry,
Oh,
right?
okay.
So they have to chip stuff off, so we can actually hose it down or reuse it, right? Because it doesn't cure. It only cures in the process in the presence of CO2.
Oh, oh. Okay, Chris. So what? All right. When you came across this whole thing, I mean, what was that? What was? I mean, you got to give us the aha moment. And you're like, wait a minute, I'd like to
Well,
get into this business because this
well,
sounds
first of all, yeah.
remarkable. Like this sounds like
So yeah, the aha moment took a year. Okay, like
okay.
I'm not gonna kid anybody. Like I'm not starting another company. That was like,
You were
then
like
it became,
done with the
I'm
pre
done.
solar that killed
Yeah,
myself on that. Done. Sold it. Ejected. I'm good.
exactly. I said I'm not doing another thing. Then like you slowly get into it. I'm like, wow, that's pretty cool. Why, like we should do this, Like, but then I'm like, ah, no. And then so it took a year, right? And
All
then
right.
and then we started making full size blocks. I said, man, this stuff works. Like this stuff totally works. It's not in the lab. You can actually we made full scale products. We've already done a phase one of our pilot. We're getting ready for phase two, doing our capital raise right now, and it's happening. And it there was no aha moment. It was like the plotting of everybody thinks the startup's easy. It's like you're plotting through 5 feet of snow, like for years basically, until you reach a paved road.
Right. It's like a one step at a time, but it's also a process of discovery, right? Because wasn't your expertise, right? You were in solar industry, and then you kind of come across this process, and you like have to verify: is this for real? Can we really do this? What does it really cost? What is it? What's it going to involve? But I mean, you just checked off all the things. It's just it absorbs CO2. It's cheaper. It's a better product. That means if it's cheaper at scale, right? Perhaps it's not cheaper right this second, but if at scale, then that means that
It's a
they could sell
no-brainer.
it. They could sell it at a little bit of a premium because it's a green product, but they could make more money off of it. And
Yeah,
because you're not using all that land to store for 30 days, I didn't know that that's what you had to do with the
and
cement process.
and there's the carbon credits as well that are being generated. So it just goes on and on. But like like let me just bring you back 20 years ago. If you were doing this podcast, and you sort of I was in solar power, you'd be asking me the same questions like, what's wrong with it? And there is nothing wrong with it. That's why like 100% of the new power plants in the United States are renewable energy now. Like it's a no-brainer now, right? Like the industry is like 100 gigawatts a year. When I started in it, 2005, it was 1.8, gigawatts. So it's a question of like just getting onto that curve, and heading towards the goal, right?
Right. But it's not always the case with every product or that's out there that's, more sustainable or more green. I mean, you kind of like you think just the amount of effort to, on our personal lives, how do we, minimize the amount of packaging and minimize plastic, whatever it is you're trying to do. It's extra effort is what it feels like. But, you're targeting an industry that needs some kind of change, and you have a solution that's even better than the original. That seems rare, or is it me? Does it seem rare? Maybe that's just the old stigma stuff we carry from trying to become more environmentally green or more green.
Well, there's always pain in changing, right? And
Sure.
quite frankly, before 5 years ago, yeah, we were concerned about CO2, but now it's like front and center, right? I would say you know, and I'm talking about everybody, right? Like not just like scientists or like climate change people, right? Like it's front and center now, and obviously the pandemic, like everybody thought World War II was terrible, right? But it did not affect every single human being on this earth. The pandemic has affected every single person on this earth, and quite frankly, this is just the trailer to the movie called Climate Change.
Yeah, we've covered that. We've covered that with a couple of guests that are experts in pathogens, and they've been ringing that bell for a long time. And it's sort
Okay.
of the description was this was actually a shot across the bow. So
Yeah.
the no disrespect to anybody that actually lost family members or something and friends in this pandemic, but it can get worse. It can get a lot worse, and it seems like we should be expecting the a frequency of this increasing as well as climate shifts, right? So anyway, we don't have to go into that because I want to more understand better this business that you're in. Holy crap! I mean, this how do you what's your current customer base that you have a sense of right now? Just give us a sense of your operation. You're 25 people, so it's growing and you're getting investments. What's your market reach you're looking
So,
for?
so the way it works with us is we've got to identify steel slag, right?
Okay.
And then we got, and then around there we draw like a certain radius around where it makes sense to
The
transport
truck
the slag
move.
to, and then we effectively establish a cluster of companies, and then they get fitted out with the technology, and then they start producing. So, we've basically got the plan for our first cluster, as well as customers signed up, in the form of LOIs, to get them integrated and producing product with our process.
It, and then but then so and then there's the proof of concept. I mean, they have to then sell it into their distribution channels, right? And they have to explain it. So there's probably a lot more people interested in hearing pitches that have this potential stuff, right? But what other areas are you trying to get? Are you trying to get local government to help to sort of stimulate some of this? I mean, there's carbon credits, but is there anything you can do locally if you're focused in a small region?
Yeah, I mean, fortunately, we live in Canada where there's lots of support for things like this. So we've been widely supported by the Quebec government as well as the Canadian government, and we're looking. We're talking to them for more for this first cluster. We're asking them, say, hey guys, like all it takes is cash and like some engineering and basically getting things going. And so that's where we're at. And the same in the States. I mean, I think in the U.S. the new infrastructure bill is gonna drive some change, which was just signed yesterday. And there's already low carbon content concrete bills that have passed in New York, New Jersey, and now California. So it's starting, right? And basically, if they give you a 5% bonus or some sort of a benefit,
It's
right?
kind of
5% is huge. In terms of
scale.
a
Yeah.
scale, because they don't make huge margins, right? Doubles their margin, right? So it's big news.
Yeah, I think the positioning of your company is like the perfect timing, right? Because you're not having to explain this from the start. There's already people looking for solutions that they're trying to find. I bet you're in a spot where it's more of like, can you get us this stuff? Can you scale quickly enough into these areas? But further market pressures are going to bubble up. It's not just when you just think of in the US, if you just think of like what New York and California is doing, then everybody else is kind of like, that's just because, a bunch of liberals live there, right? It's not going to really impact the rest. But again, it goes back to this thing. This thing costs less to make if you
Yeah,
got
and
the
like look, like I came from the solar panel industry. You have to have it cost the same or less, right? Like people they want to prove that they've got a bigger recycling box, but don't want to have to pay for it, right? So you have to, like, you just have to show them the truth, and get them to understand that it's the same or less, and then that's when things start to scale.
don't share proprietary information on my show, but I'm sure there's some patent or proprietary aspects to it. What typically is in this area? What's that area in
It's the carbonation of concrete building blocks using steel slag. There's IP, there's patents that've been granted in the United States, Canada,
Oh,
Europe,
in the US and can't. Okay. So I could actually
India.
go to the patent office and look it up and go, okay,
Yep.
that's what you guys, you know. And so is this like a licensing thing? Like are you open to that? If there's somebody else here in the US that would want to
So
do
that is our
that,
business. Our business is to license the
is to
technology.
license.
Yeah.
Okay. We
Yeah.
have the license, we have the know-how. You organize the trucks, you invest in the machine. Do you make the machinery or is that
No,
comes from somebody else too?
no,
Okay.
no. We're engineering our commercial curing chambers right now, and that's what's going to be installed for the phase 2 of our pilot. And those curing chambers will be the ones that get replicated on a modular basis, installed at all of our licensees.
And that's the that's the big capital investment, right? Getting that engineered in a sense.
Yeah, it's not huge,
Okay.
but it's like if you started off from scratch, it would represent about 10% of your 10% of your cost. But if you made a greenfield plant from scratch, our plant would cost about the same as a regular concrete plant. So there's not a huge difference.
Okay, hold on. Can you break that down a little bit? Because that's part where I don't quite understand the
So
green.
yeah, greenfield means like let's say you said I'm building a masonry plant, a brand new concrete plant, 25
Okay.
million bucks. Okay, let's say it's 25 million bucks.
Okay.
That whether or not you pay $25 million to have our technology or regular cement-based technology, it's the same price, right? It's there's no material difference from the ground up. Where it gets different is when you have an existing plant and when you're changing it over to our technology, then you have to invest a bit of capital into the curing systems. But with big companies, they don't care; they'll put it on their balance sheets. But for us, we're raising capital so that we can lease back equipment that we provide on their sites, so that the customer doesn't have to pay for it up front.
Oh, okay. So you'll bring the equipment, part of the leasing agreement, then they get to use the equipment, make and start making business, continue on with it. But this is something for the retrofitting guys, right?
Yeah, exactly.
Okay.
Like that's not the case for everybody. We've been contacted by a really large multinational in France that has 20 plants. I was on several calls with the CEO of this company. It's a $9 billion corporation. They want to basically convert all their plants. They want to pay for the capital required to do that. They want to pay for certification in France, yada, 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 right? So that's the kind of interest level that we've got. And it's not just them. There's other integrated cement and concrete companies that have taken obviously an interest in us.
I mean, the fact that you'd have the old way of storing that's something that takes 28 days, you can get it down to 24 hours. I mean, that alone, just the amount of to get to volume, the volume deliveries, to be able to do it faster without storing as much in a giant field. I mean, is that a major driver for some of these decisions or not? Like it just
Well, if you're building a new plant, for sure. Like anybody that's building a new masonry plant should not build a regular cement-based plant.
okay. Said it here on this show through the noise. Bottom line, don't do that.
Yeah, exactly. Yeah, it's like building a new coal-fired electricity plant.
Don't do that. Don't go there. There's options. There's options.
Yeah.
There's better options now. Okay.
Yeah.
Wow. And I guess this is. I mean, what's the competition look like? There's got to be others like you guys out there, or maybe not. I don't know.
There's not really others that are commercializing steel slag as a binder.
Okay.
There's other alternative cements being touted and used, by different companies. But it's not like completely inundated with technology at this point. It's pretty much the Wild West still, because it's like I said, it takes a lot to change an industry, right? But if you can come with and most of those other technologies are much more expensive, and that's been the holdback for some of these other techs. So it's obviously, if we can come with a cost competitive way to do something differently, there's obviously a lot of people interested.
And is the what's the sort of sales landscape look like for you guys? I mean, do you have to do a lot of marketing for this, or are people just finding out as things come online that you have this process and they want to know more?
The only outward bound call I made to a customer was for our pilot customer. All the other customers have come to us, including that company in France, including the company in a very large Irish integrated cement and concrete company. Like they just find out about us. It's same thing on the steel side, right? Like the steel companies are calling us because they've got this issue, right? They want to get rid of their steel slag, and like they're selling it for $5 a ton as aggregate. They can sell to us for $5 a ton and sell all of it, not just the big chunks, right? All the little bits too.
You'll take as much as you want, not have to sift through that. Okay.
Yeah.
And the steel slag, just to explain to people, that's the stuff that's left after burning creating the steel beams or what all the crusty things that at the bottom of the pan or whatever of the steel
Yeah,
making
yeah,
process, right?
yeah. I'd like to refer to it as the gravy. That the crust on top of the gravy. No,
Okay.
but in all seriousness, it's basically a hard mineral that's formulated when you melt the steel.
And and so when you think of the potential scale for the business you're in, I mean, I don't know. I feel like the solar industry must have been pretty tough. You're climbing. I don't know what you did there, but if you're, there's a lot of roofs involved and homes and a lot of homeowners that don't understand what's going on. Here, you're like big industry guys. They just got to get one presentation, work through the numbers. The thing sells itself, it seems like, right?
Yeah, I mean, yeah, well, yeah, it does sell itself, but you have to prove that you can do it, right? So, we
Right.
have an R&D lab, a development lab. We can show people how it's done. You have to demonstrate, rather than, you can't just show PowerPoints. I can go pretty far in a PowerPoint, but like eventually you have to, show something, right?
Right.
So that's why we built our R&D facility, which is in Montreal, and that's where we bring clients.
And so you fly them in and you walk them through the process, and then you show them some of the end products, and then you show them the numbers associated.
Yep.
And then the decisions sometimes you get made right there, or do they
Well,
walk
the
out
thing is,
kind of?
is that if for us we need to have business planning, right? Because it comes down to, where are we going to set up the next cluster of companies, and then because it comes that we have to identify the steel plant, make sure there's a deal there, figure out how much of this a Slag they produce every year, qualify it, and then we can go out and say, hey guys, or gals, we can
In this area.
we can do this here. So, like you asked for like the one fallback or setback, it's basically it's geographically located, right? You have to, but so is cement, right? You can't make cement without limestone. So all the cement plants are next to limestone, right? So
Right.
the it's the same idea. It's geographically sort of positioned, but fortunately, most steel plants are not too far from urban centers, and there's always a lot of masonry plants, close to urban centers.
I take it that if you had to fly out to meet any of these guys, you go through interesting parts of the world to see where their operations are, right?
Yeah, I mean, if yeah, I haven't flown in a while, but
Right.
the one day I will again.
We're
The
close.
Yeah, we're this close. Yeah, I mean, look, we're on North America now, probably Europe next, and obviously the in Asia, in China and India are massive steel and concrete users, right? 50% of all concrete in the world used in the world today is used in China. Same thing with steel. 50% of the steel, right? It's imagine that. It's so 50% of the market, our target markets in China.
And then, I mean, do you have, I don't know, perhaps as an American, we're constantly bombarded with the, questionable Chinese business practices and technology and so forth. I mean, but I mean, this is, this is big industrial stuff. It's not that easy to just simply copy some plans and then do it yourself. I mean, do you have, concerns around that, or is this sort of like, no, we just gotta get involved and help them transition, do the best we can?
Do the best we can. Like it's basically, try and put as much blockers as possible, like with patents, as well as, controlling the supply chain and how the materials get to the customer. That's the only way, you can control it. For sure, things are going to get ripped off, but you know, yeah, it's you can do your best.
Yeah.
Bigger, with big partners.
Right. Don't accept imitators.
That's right.
CarbiCrete is the
Yeah,
brand you want.
that's right. That's right. So it's not like buying a Burberry handbag in the back of
No.
the American Embassy in Beijing, but which may or may not be really from Burberry, but
Well, I can kind of imagine that, like, you want to make sure that it is the process that's involved in creating the concrete blocks that then are resold to the builder. Like, the builder's going to want to make sure that actually is that house we're building or the bridge we're using, the stuff, whatever it is going to actually stand the test of time, right? And you don't,
absolutely,
you
yeah,
don't, and so I'm sure there's a ton of due diligence that's involved in all of this stuff, getting construction materials overseas from anywhere, right?
yep. Yeah,
Hmm.
absolutely. Yeah. So we're going to tread lightly, I think, in those countries and try and control the process as much as possible before things get a little bit haywire.
Right. Do you feel the pressure already in the kind of the incoming pressure? I mean, it's probably you have probably challenges that many startup entrepreneurs would love to have. Compelling product, compelling price, compelling, concepts. What more could you ask for? But then you have the challenge of like getting the operations quickly enough that it doesn't, get discombobulated as you're growing your
Well,
business,
I
right?
mean, to your point, I mean, it's not like we've got like 30 people in the basement of a building, like tapping out code. Like
Right.
there's no risk there, right? It's just people's time. Like we're talking about like getting equipment built, installed, running properly, making supply chains are happening the right way. Like that's a lot of effort, and that's no small effort, I should say. And so that's the type of stuff that keeps me up at night.
Well, I'm going through a bathroom reno in my home, and let me tell you, it's been about a month, and it's I set myself up for the surprise quick decisions you have to make along a process that exists. But you're building big machines into big space, into big, serious operations. So I'm sure it's a lot of project management in that, and managing client expectations along the way. But
Yep.
the end product is the winning scenario here. Where do you find, other than China's potential, given just the sheer market size, where do you find what regions are like more like into it than others? I
I
would
would,
have
yeah,
put
Europe would for
Europe.
sure. Yeah, yeah. There's a ton of interest in Europe. They're a bit further than us in North America here.
Is that an
There's
understatement? Is that just
yeah,
being nice? Are you
yeah.
being nice?
I'm being nice. Yeah. When it comes to the
Just give it
environment,
to
yeah,
Chris. Give it to us straight for real. Like I'll take it from my
we're
Canadian friends.
terrible. Yeah, no, yeah. Canada, and the United States are terrible, but we're getting better. We're getting better. No, but in Europe, obviously they have more constrained supply chains. They have more people, per square meter, foot, whatever you want to call it. And there's always been that sort of notion of trying to be like cleaner or more sustainable, and that's not something new, right? Like that's been going on for years. I think in North America, I think we're slowly getting there. Uh, you know, it's just it takes
We've
some
had a
time.
lot more space, so we don't really think of the damage. We just buy the field across the road or the highway or whatever, and we weren't really thinking in terms of being efficient in transport. And so I guess in
No,
more densely packed areas of Europe, right? So
yeah,
it kind of makes sense. But that might be, at the end of the day, that might actually benefit us because we can kind of see all the effort that Europe does, and we can just kind of pick off the best ideas, right?
yeah,
And
yeah,
start to,
exactly, yeah.
you know,
Yeah, no, I agree with you. I mean, usually California is like a leader. I would say in the province of Quebec, we're also leaders in terms of environmental stewardship. Um, it, it- you know, it's going to happen, right? It always happens. Like the cars that were sold in California were always the cleanest cars, if you recall, 20 years ago, and that became the new standard for everybody. Uh, and it just keeps going that way.
do you look at your growth rate, like where do you project out 4 or 5 years where you think might be like when you're talking with investors that are going to want to return their cash in 5 years or something? Do you have things mapped out where your growth rate? Have you thought through all that, or is it just still
Oh yeah,
putting everybody
no,
quickly
no,
together to move this forward?
no. We've got an entire business plan for the next 7 years, which is conservative. So we can outsize that. After we've got this next round of equipment going in, we can basically design what the business looks like going for the next 5-7 years.
What will be? I mean, if there's somebody out there listening to this, what kind of workers are you going to be looking for that you're going to need help with in this type of role that you guys are in?
Always engineers and basically R&D people that can qualify slags, invent new products, improve the process. Um, you know, people that can get our process installed at a new plant in a new country, like under whatever circumstance, right? Because in a new country, it could be difficult. So that's the type of people that we're looking for.
I guess not quite so much the slick sales guys, but more consultants out there that might have industry contacts, that might have people they've known and trusted relationships, that kind of thing too.
Yeah,
Or
yeah. Like, look, we're not trying to reinvent something. There's the whole concrete business is huge, and there's lots of people in it that want to do something different. So, I'm not from the concrete industry. So anybody that is listening that is in that industry, we're interested to talk to you.
And what are your thoughts on like the typical like concrete associations and things that are out there? I think there's like a stone gravel. No, that I can't remember exactly. I've had so many associations on my show in the past that I can't remember them all. But what are your thoughts on just sort of those membership based groups?
I mean, generally the people that run them are you know they know where their bread is buttered, right? So anybody that's paying the membership fees has to sort of toe the line. So generally, um, originally they were not that receptive to what we're doing, knowing full well that they still have to decarbonize. But now it's a different story. We've been shortlisted to the Global Cement and Concrete Association's piloting program, whereas 5 years ago they wouldn't. I don't think they would talk to us. So there's definitely a sea change happening. That's clear. The bullseye was started off on the the electricity generation market, and then the bullseye transferred to the mobility market. Until
Tesla.
yeah, until like the electric car was invented, no, or reinvented, whatever you want to
Reinvented.
call it. Yeah,
I didn't.
yeah,
I just only recently found out that there were electric cars 100 years ago.
yeah.
we just
Oops.
we
Yeah,
just we missed the boat on that one.
no kidding.
We
Yeah, so,
decided to get the leaky, oily car. So we
yeah,
decided to go with that for a while for some
yeah.
reason.
For a while, yeah. Yeah, until like 100 million of them are running around the roads or whatever that number is, and so the bullseye has switched really to agricultural, steel, and cement. It's cement is a very difficult to decarbonize industry. Same with steel. Agriculture, they've got pathways, to improve those, and cement, we're trying to solve a part of it, right?
I mean, yeah, you still have to, the energy that a steel plant or, cement, maker, you might be still using fossil fuels just on because of the sheer scale. I don't know if we have to then like create small nuclear power plants to stick next to them so they can continue doing what they're doing. But we need steel and we need concrete, but we got to figure out a better way. And it sounds like you have like this little the right spot. And it seems like it was just sort of overlooked in terms of the steel slag.
Yeah, because nobody wanted to use steel slag because it doesn't hydrate. It doesn't cure in the presence of water. So like this is a terrible adder. Why would we use this?
Okay.
So basically that's why it's been a castaway. But then like my business partner discovered that you can react this with CO2, in certain conditions, and it makes concrete products.
Do you need heat in that carbon is what do you call it?
The curing process.
Yeah.
So the carbonating process. No, you don't need heat. It actually
you don't need heat, just the gas.
Yeah, it generates heat. So the blocks come out warm.
It'll do. Oh.
Yeah.
Shit. Wow, Chris. Okay, so when are you going to go IPO? Where are you listing so I can buy some shares?
Yeah, soon. Yeah. No, it's funny because there's a lot of investment banks that have been calling us, right? And we're like, well, whoa. We'd like to, we want to get things sort of on the path that we want to get them on, right?
Right. I guess you probably take some inspiration from the Tesla story, perhaps. I would say. I mean, this sounds really promising, and I'm really excited to get the opportunity to actually talk to you, even so briefly of an hour. But I'm sure you're super busy, so thank you, Chris. That was an hour. We just went through it. I really appreciate it. Let's please keep in touch. And I want to keep hearing as the story evolves for you guys. Cause literally I just sat down to look through a little bit, my show broker got you guys on. She's like, you gotta check these guys out. Okay. And then just quickly realized, whoa, this is legit. This is like, you're grabbing CO2 out of the air, sticking it, well, not out of the air, but you're applying CO2 into the product, and the end product's actually a better product.
Yeah, and we get rid of CO2 forever. So who doesn't like that?
Who doesn't? Yeah. Every concrete, cement, they should be transitioning to this thing. So I'm sure at some point you're going to be overwhelmed. So best of luck to you. You're probably overwhelmed now. So best of luck, Chris.
A little bit, but it's all good. Thanks, Ernesto.
Take care. Thank you.
Visit throughthenoise.us for more episodes and subscribe to our newsletter. This show is produced by Through the Noise Consulting, uniting external communications and internal IT functions to ensure data and privacy are protected while creating innovative communications platforms. Want to start your own podcast? We can help. Visit getthroughthenoise.com to learn more.